In this example, we're going to add these two fractions. Notice, however, that in the denominators we have complex numbers. The process we use for adding these fractions will be exactly the same as before. It's just that now we're going to be using complex numbers instead of whole numbers. Well, to begin, 3 minus I and 3 plus I don't have any common factors, so the common denominator that I'll use is just the product of the two. So I'll do a fraction bar here, and I'll say 3 minus I times 3 plus I, and that'll be our common denominator. So for the first fraction, we have 3 minus I, but we don't have the 3 plus I. So let's go ahead and multiply by the 3 plus I. And for the second fraction, the denominator was 3 plus I, but we don't have the 3 minus I. So let's go ahead and multiply by the 3 minus I. And as we shift over here, we can do a couple of things. In the numerator, we can go ahead and distribute. So it looks like I'll have 15 plus 5I, and then plus 6 minus 2I. And then in the denominator, it looks like these two complex numbers actually have a nice relationship. They're actually complex conjugates of one another. So when I multiply, I just need to multiply the 3 times the 3 and the negative I times the positive I. And if you were to multiply all the terms, you'd notice the middle terms will cancel out anyway. So I'm only going to mess with the first and the last. So 9 minus I squared. Well, in our numerator, we can simplify a little bit more. 15 plus 6 is 21, and then 5I minus 2I is plus 3I. Over, what we have here is 9 minus I squared, but really I squared is negative 1. So 9 minus a negative ends up being a 9 plus a 1, so that's a 10. But the last thing we need to keep in mind is we have to write our answer in standard form, a plus bi. So we'll have to separate this denominator out. So 21 tenths plus 3 tenths I. And again, we need to ensure that it's a plus bi. So the 3 tenths, which functions as the real part here, this b for our imaginary number, needs to be separate from the I. So 21 tenths plus 3 tenths I will be the answer when we add these two fractions.